Hello and welcome to yet another video of Cornerstones of Math, and welcome to yet another South Korean College Scholastic Ability Test video. This is the test that South Korean high school seniors take at the end of the year to apply for the college in the following year. Today, I want to address this problem. The figure shows a portion of the graphs of functions y equals 1 and y equals 0. 2 points a 0, 1 and b 1, 0 are connected using the graph of the function y equals ax cubed plus bx squared plus cx plus 1 defined on x greater than or equal to 0 and less than or equal to 1. Values of constants a, b, and c are determined in a way that the function representing the entire connected graph is differentiable on the entire set of real numbers. Find the value of a squared plus b squared plus c squared. Okay, let's see how this can be done. So we have a cubic function ax cubed plus bx squared plus cx plus 1 in the middle. And let us use f of x for this cubic function. Obviously, we are also going to use its derivative, which is 3ax squared plus 2bx plus c. In order for the entire graph to be differentiable, it must be differentiable at two boundaries, x equals 0 and x equals 1. Two conditions must be met at each boundary. First, the graph must be continuous at x equals 0 and x equals 1. In other words, the y value approaching from the left must be equal to the y value approaching from the right. At x equals 0, we have f of 0 equals 1, which is already satisfied. At x equals 1, we have f of 1, which is a plus b plus c plus 1, must be equal to 0. This gives a plus b plus c equals negative 1, and this is our first equation. Second, we have the same slope condition. That is, for each boundary, slope from the left must be equal to the slope from the right. Mathematically, this means that the value of the derivative must be equal from the left and from the right. In this case, derivatives at both boundaries must be 0. So using this derivative, first, the derivative at 0, f prime of 0, which equals c, must be 0. This is a rather simple result, but still let's call this equation 2. At the second boundary, f prime of 1, which equals 3a plus 2b plus c, also must be 0. Let's call this equation 3. The second equation straight up gave us c equals 0. If we substitute c with value 0 in first and third equation, the first one becomes a plus b equals negative 1, which I will call equation 4, and the third one becomes 3a plus 2b equals 0, which I will call equation 5. Let's do equation 4 times 2 minus equation 5 to eliminate b. So if we multiply 2 to equation 4, we have 2a plus 2b equals negative 2, and equation 5 is 3a plus 2b equals 0. If we subtract this, b is eliminated, and minus a equals negative 2. So we have a equals 2. Then from equation 4, we have 2 plus b equals negative 1. Hence b equals negative 3. So with all values of a, b, and c determined, we can calculate the value of a squared plus b squared plus c squared, which is 2 squared plus negative 3 squared plus 0 squared, which is 13. So we have solved the problem, but this is only for a very specific case with the graph of y equals 1 here and y equals 0 here. So the naturally occurring question is, can we generalize this to the case where these two graphs are arbitrary?